Torrential rains reveal engineering flaws in Southern California. Million-dollar homes slide down a cliff, and a major road becomes a gigantic sinkhole. In France, the roof of a monumental airport terminal collapses. Off the coast of Virginia, an aging coal ship sinks in rough seas, killing 31 mariners. A deadly plane crash changes the face of passenger aviation. And a tiny imperfection creates big problems for one of the most acclaimed structures of the 21st century. Now, engineering disasters on Modern Marvels. Persistent heavy rains wreaked havoc throughout Southern California during the winter of 2004-2005. Los Angeles received 37¼ inches of rain that season, making it the wettest year the City of Angels had seen in 121 years. But months would pass before the rains caused some of the worst damage. On the perfectly sunny morning of June 1st, 2005, residents of Bluebird Canyon in Laguna Beach, California, were awakened by strange noises.
I heard really loud popping. It almost sounded like a BB gun, like kids in the canyon. And when I realized it was coming from under the house is when I kind of panicked.
So at this point, I ran back to the front of the house. I opened the front door and I actually saw my curb separating from my walkway. We could feel the house moving and it was very loud, the cracking, the popping.
And we ran outside. I think we were the first neighbors out, but they quickly followed. Everyone was screaming, asking what happened, what's going on.
What was going on was that a 7-acre wedge of land was breaking away from the hillside. It would send these residents and their homes sliding down the slope. Houses cracked, streets buckled. Residents ran for their lives.
And I grabbed my 2-year-old out of the crib. My ski pajamas, I just pulled my arm. I knew it right then. The house was sliding. I didn't know what to do, so I just ran into my 4-year-old's room and I put out my arm and I said, "Get up and grab Mommy's arm." I said, "The house is breaking."
Well, I guess, you might say all hell broke loose. We tried to get off the street, but as we tried to go down the road, the street actually opened up. It rose probably about 30 feet into the air. What we didn't realize was that the street was falling, that these houses were coming down.
Flamingo Road, located near the top of the hill, and the houses on it plunged about 75 feet.
What happened is over 500,000 cubic yards of earth gave way and literally avalanched down the hill into the bottom of Bluebird Canyon. And that's about the same amount of dirt that would fill over 10,000 swimming pools. It's a lot of mass moving very fast with a lot of energy.
Now, when this landslide first occurred, many of my colleagues were kind of surprised. It wasn't a rainy day. I'm used to landslides happening on a rainy day. Well, deep-seated landslides like this don't necessarily happen on a rainy day. They happen when the water table has been elevated, and it takes many months for water to percolate down deep into the earth.
Usually, seasonal bursts of heavy rain dump 12 to 13 inches on Southern California. The rain runs off before it's absorbed. However, the 30-plus inches of rain that soaked the area during 2004-2005 was a persistent rain over a long period of time, saturating the earth from October to May.
This landslide is a bedrock landslide, and the bedrock in this area is what we call the Topanga Formation, and it's a mixture of sands and silts and clays. In particular, there's a layer at a depth of anywhere from 50 to 80 feet. The clay that the landslide failed on is a very plastic clay. And by that I mean, when you get it wet, it's a consistency of Play-Doh. Not very high strength material. So when you tilt that up and then you compound the problem by having a very heavy rainfall year, twice normal rain, that builds up water into this and softens the clay, that led to the failure.
The deep landslide claimed 20 homes, but miraculously, no lives.
The interior structures of the homes are just crumbled into hundreds and thousands of pieces. Walls fallen down, granite countertops broken in half, cabinets ripped off of walls. It's complete devastation in most of these homes that you see behind me.
I would call this an engineering disaster simply from the failure to recognize that this was a hazardous area. That's a great challenge, and it's one thing that geologists need to do whenever they investigate an area for new development. But clearly, in this case, in retrospect, we can tell that this was an unsuitable place to build houses.
This was not the first time a hillside gave way in Bluebird Canyon. A huge landslide consumed part of the neighborhood on October 1st, 1978. Just a few hundred feet from the 2005 landslide. 24 families lost homes then. Most of the homes on the hillside were constructed before building codes were as strict as they are today.
At the time these houses were built, there really wasn't any kind of geotechnical analysis or geologic assessment of stability. They more or less just came along and graded a flat pad and built their houses. I'm confident that they didn't know what kind of risks that they were facing.
In August 2005, red-tagged homes were demolished and a massive hillside reconstruction project began.
We're attacking this slide stabilization in several phases. The first, most important things we have to do are to get the canyon opened up and put in a storm drain system. And secondly, we're going to be stabilizing the headscarp area so that we don't lose more homes and possibly a street up above those homes. We'll be putting in caissons and tiebacks up there. And we'll also be removing all the homes on the landslide and regrading it to seal the fissures and try to establish drainage so that we don't end up with a lot of mud and debris flows.
When we're all done with the repair plan, we will have put back the slope that was there before, but way better. It will be anchored into the bedrock like it should have been in the first place, and we'll have put in with it proper storm drains that will, when it rains hard, will collect that runoff and get it underground in a way so that it doesn't saturate the soil and mobilize it again. And it will be a perfectly safe building site following current building codes today.
The cost of the repair plan is estimated at over $10 million to be paid by the state, the city of Laguna Beach, and Bluebird Canyon residents. Most residents plan to move back onto the hillside once it's repaired, placing their faith in the skill of engineers.
When you wonder whether homes should be built in places like this at all, when they have discovered these kind of geological risks, I think the answer still is yes, carefully, surgically. As far as this disaster goes, it is a disaster because of a lack of engineering. Had there been proper engineering before and during the house construction, this would have been prevented.
While this disaster came months after the Los Angeles storms, other engineering disasters occurred during the height of the rains. February 19, 2005, after weeks of downpours, rainwater filled a crack on busy Tujunga Avenue in Sun Valley, California, a part of Los Angeles. Quickly, the crack expanded.
When I first heard about the hole, I was just starting to leave work on a Saturday morning, and we noticed that the sidewalk about where it starts right there was starting to cave in.
Within a few hours, the fissure had turned into a 30-foot-long fault that bisected the road. Initially, the hole measured about 40 feet in diameter. But the sinkhole kept growing. The rushing water and falling chunks of roadway crushed a sewer pipe and severed a power line, turning the roadway into a virtual river.
We came back on Sunday to help them to fill it with concrete. It had already caved in under the street, and it was starting to go back gradually as it rained more and more. It was raining the hardest I've ever seen since I worked here.
A neighboring business provided city workers with 250 cubic yards of concrete to help fill the sinkhole.
We were trying to pour concrete inside of the piece that was missing, But every time we poured it in, the water was just washed away because the water was coming so fast and so hard that it didn't have a chance to stick.
The chasm eventually swallowed more than 200 feet of pavement. 250,000 cubic yards of soil would eventually wash away. To make things worse, ᴍᴏᴅᴇʀ Avenue was flanked by a landfill on one side and a sand and gravel pit the size of a football field on the other. The growing sinkhole joined the existing pit. At 10:30 p.m. on February 20th, Public Works Supervisor ᴍᴏ was monitoring his workers as they repaired the sinkhole. Suddenly, the ground he was standing on caved in.
I'm watching him from the other side, and no more, all I hear is this noise and the rumbling of the metal and the wash and the rapids.
The truck was parked on a piece of the road that was hanging over, and when it started to crack and they could hear the road breaking away, he tried to run up to the truck. I believe when he got in, or he got up next to the truck, the street just caved in and the truck fell in the hole.
ᴍᴏ died in a raging torrent, falling victim to a failure of engineering. ᴍᴏᴅᴇʀ Avenue had been built over a dry riverbed, without an underground pipe system or curbside channels to divert rainwaters. In Southern California, dry river or creek beds called arroyos are subject to winter flooding.
A key point to understand is there is no such thing as a former riverbed. Water continues to flow into the area. Water simply doesn't flow on the surface. It has to go somewhere. Or it's going to percolate through the sand and through the gravel, whatever else is under there, it will percolate.
Or if you have in your road a significant crack, as we often do have in asphalt pavement, that water with its energy will be scouring the underlying bedding through that crack. Once you start at a crack, that crack now from the edge of the road will be unzipping that crack upstream to where the water is coming from. And eventually you will have this huge, huge, massive hole.
Still, the placement of ᴍᴏᴅᴇʀ Avenue is not unique.
Where the bottom of the canyon, or at least close to the bottom of the canyon, is always an attractive place to run a street, run a road. Historically, people did it for thousands of years. But what needs to be taken into consideration is the fact that those streets do become a water collector, and that they cannot be left to their own devices in handling of that water.
Today, the hole remains, a visible reminder of the damage caused by heavy rains and lack of drainage on ᴍᴏᴅᴇʀ Avenue. The city estimates it will cost up to $100 million to repair the hole and build a proper flood control infrastructure. That could take years. From 1969 to 2004, presidential disaster declarations were issued for 60 landslides, 12 of which occurred in California. Engineering disasters will return on Modern Marvels, here on the History Channel. On June 25, 2003, France celebrated the grand opening of Terminal 2E at Charles de Gaulle Airport in Paris. However, an engineering catastrophe would turn jubilation into mourning before its first anniversary. Terminal 2E was part of a projected state-of-the-art four-terminal hub for Air France. It was being built to handle up to 17 planes at once and 10 million passengers a year. Aéroports de Paris, or ADP, the airport authority for the Greater Paris region, in collaboration with Air France, spent almost $1 billion to build the innovative structure, made to show off French engineering skill and panache.
It's just a joyous space, and you need a joyous space when you're coming off the transatlantic flight at 7 a.m. and you're going to be in the airport for a few hours waiting for another flight out. The architecture matters.
A structure with no interior columns, the futuristic tunnel was admired by many, including travelers and workers who arrived at the terminal on May 23, 2004. 11 months after opening celebrations, Suddenly, several tons of concrete, steel, and glass collapsed as a 98-foot section of Air France's boarding lounge roof fell in.
It's very long, but it's also huge in the span. It's nearly 100 feet wide. The concrete on one side slid off the support and fell to the ground. On the other side, the concrete literally flattens the roof of the oval, comes to the floor now, sits on the floor there. Huge amount of concrete. Remember, we are talking 1 foot thick concrete. So that's a lot of weight. That's 60 pounds per square foot.
When the heavy concrete roof crashed, it killed 4 people and injured 3 others. The collapse astonished many engineers and designers. Just months before, the terminal had been praised for its technical prowess. How could it fail? Clues lie in the startling design. The roof of the boarding lounge consisted of a concrete vault, pierced with openings to allow light to pass through, and an exterior metallic structure on which the glasswork was fixed. Pillars supported the entire construction. The oval-shaped structure sat inside a glass shell, where the temperature and environment were constant. The glass encasing rested on tensioning cables that kept the oval from bulging out.
It's a structure that gets stronger the more you press on it. And the classic compression structure that people know about is an egg. If you think about an egg, very, very thin shell compared to the size and weight of the egg, and yet it's actually pretty strong. It takes some work to crack that egg. On the other hand, if you get an egg that has a crack in it, that did develop a crack, it's very weak structure.
On this unusually cold May morning, the terminal's concrete structure was extremely fragile. Prior to the collapse, the temperature dropped sharply from 77 degrees Fahrenheit to just 39 degrees. The cables are exposed to fluctuating outdoor temperatures that cause them to expand and contract more than the concrete. On a hot day, the cables expand and slacken, reducing structural support and increasing the likelihood that cracks will form.
Now comes an evening after a hot day. The cable suddenly cools down. We know that just prior to the collapse there was a massive drop in temperatures. The cable shortens. What happens when the cable shortens? It wants to straighten out. It cannot straighten out because the struts are holding it in the position where it is. The force in the struts is increasing dramatically.
But the concrete was designed to handle the extra force from the struts.
But when you start dealing with those changes in the forces in the strut that I described to you, related to temperature, related to the concrete now, when it cracks, it becomes much more flexible, so it's no longer the rigid structure. The strut punches through, the concrete shell loses its support and goes flat. And that's what happened.
The perfect eggshell was further compromised by necessary structural elements of the terminal.
In the section that collapsed, you have 3 very large entryways right next to one another, 3 protrusions that mar the perfect smoothness of the shell.
That disturbs the symmetry of the structure. No longer can the structure redistribute the loads freely. If one area gets slightly overloaded, you have perfect symmetry, it will shift the load elsewhere. But if you have those sharp discontinuities, such as a hole cut in it, that's no longer a nice and self-adjusting oval symmetric structure.
In February 2005, 20 months after the collapse, the French Minister of Transport released the findings of an administrative investigation. The report stated that the structure had been slowly deteriorating since its inauguration in June 2003.
And they were very, very careful about spreading blame, that, well, the metal wasn't quite right with the concrete, the foundation wasn't quite perfect, the design had a few little problems in it, but almost certainly the failure started where the shell was pierced massively from the side.
In May 2005, ADP announced that it would rebuild the damaged roof of Terminal 2E. Pierre Graf, president of ADP, said that the only way to ensure passenger safety was to replace the entire curved roof shell. The completely renovated Terminal 2E is slated to reopen later in the decade and will cost an estimated $195 million. Terminal 2E was designed by internationally renowned French architect Paul Andreu. Coincidentally, he also designed Terminal 3 at Dubai International Airport, which collapsed during a construction accident on September 28, 2004. Engineering disasters will return on Modern Marvels. On February 12, 1983, a routine shipping run from Norfolk, Virginia to Brayton Point, Massachusetts turned into a fatal voyage and one of America's worst maritime disasters.
It was a bad storm. The Weather Bureau called it the worst East Coast storm in 40 years.
The Marine Electric bulk carrier, similar to this ship, was transporting more than 24,000 tons of coal. A crew of 34 merchant mariners were aboard.
Most of the crew and officers considered the Marine Electric a real milk run. They always knew that they were only 30 miles off the coast, and if something went wrong, the Coast Guard could come out and get them.
But as the Marine Electric left the Chesapeake Bay in the early morning hours of February 11th, bad weather off the coast was setting a fatal scenario in motion. Then, in the dead of night on February 12th, the situation aboard the coal carrier went from uneasy to desperate.
And it was about 1:30 when the ship was getting into trouble. The seas, they were breaking, coming right down the deck, down to number 2 and 3 hatch. We said, we're in very serious trouble.
Her bow was noticeably heavier as the ocean waves crashed onto the deck. Less than 2 hours later, the Marine Electric was listing to starboard and going down in 29-degree water.
So we started to lower the lifeboat, starboard lifeboat. And just as we were doing that, the ship capsized right down on her side. In less than a minute, this happened.
The ship made a noise that one of the officers described like water going down a drain, magnified 1 billion times. It capsized onto its right side, trapping many of the men under the ship, spilling all of them into the ocean.
The entire crew of 34 men plunged into the frigid waters with no survival suits. 31 men would die that night. What fatal engineering flaws caused this disaster? The Marine Electric was a World War II tanker ship, also known as a T2 tanker. She was nearly 40 years old.
They weren't really designed to last forever. The feeling was you made about 30 trips, it was going to get torpedoed. Who knew what would happen?
After World War II, these ships were used as commercial vessels and oftentimes converted to different uses. In the 1970s and the 1960s, it was common for these vessels to be, in effect, cut in half and enlarged by inserting a midsection.
The common term for this process was jumboized. The Marine Electric was jumboized to 605 feet, nearly twice her original length.
Now, of course, you can probably do this safely if you go back and examine the engineering drawings and figure out how to properly increase the size and where to supplement the framing of the ship. I think it's fair to say this was never done.
Yet, while jumboizing probably weakened the Marine Electric, it wasn't the flaw that sealed her fate. Chief Mate Bob Cusick was part of the Marine Electric crew for 5 years and a mariner for over 40 years. Just weeks before the disaster, he pointed out innumerable weak spots throughout the ship, including the 40-foot wide cargo hatch covers.
I'd draw up sketches and exactly where it was, the holes, and submit them to the captain. He submitted them to the steamship company. One of those things is like a Greek tragedy.
The compromised hatch covers were not properly repaired.
We'd just keep patching them. We'd put some duct tape over them and then some, we called it red hand, where it's like Bondo you use in a hole in a car. There was over 97 different holes.
Those cargo hatch covers would doom the Marine Electric. But it would take a legal battle to reveal the truth. Bob Cusick, Paul Dewey, and Eugene Kelly were the only survivors of the Marine Electric tragedy and led the crusade.
A steamship company has to show that they didn't send the ship out in unseaworthy condition. It's a big difference if they know about it or they don't know about it.
The bitter battle started with the victims' families on one side and Marine Transport Lines, or MTL, the owners of the Marine Electric, and the Coast Guard on the other.
The official Marine Board of Investigation started the week after the ship sank. But unlike other investigations, this one was an investigation that had actual witnesses who had survived. And in this case, all three of them abandoned the code of silence and wanted to tell the true story of how their comrades died and why.
MTL set out to prove that the crew, and especially Bob Cusick, was at fault for the sinking. It hired the best underwater divers with the newest high-tech equipment to examine the wreckage.
They figured if they could show that the crew, namely me, where I was the chief officer, that I had loaded the ship wrong or hadn't secured the hatches or the anchors or something, they would have been off the hook.
But it soon became clear that the crew wasn't at fault. The survivors of the Marine Electric revealed that inspections of the ship, conducted by both the Coast Guard and the American Bureau of Shipping, were cursory at best, and in some instances, completely false. The investigation now focused on the weakened hatch covers.
Later testimony would show that the Coast Guard certified that the hatch covers were of a good quality and of a good strength, when the hatch covers at that time weren't even on the ship. What Cusick was able to show on the stand was that the hatch covers were riddled with holes, that the men were so afraid of the hatch covers that they wouldn't walk on them for fear of falling to their deaths into the bottom of the ship. They had patched them and patched the patches.
The pounding waves had burst through the disintegrating metal hatch covers and into the number 1 and number 2 cargo holds. Dominic Colicchio, captain in the U.S. Coast Guard, former merchant Marine, and part of the Marine Investigation Board analyzing the Marine Electric sinking, didn't turn a blind eye. He asked the hard-hitting questions and didn't relent under pressure. Because of his tenacity, the final report made an impact well beyond the Marine Electric case.
Essentially, the report findings said that a great number of the ships in the American fleet were unsound. The inspections that the Coast Guard had done were inadequate. And the board also said that the American Bureau of Shipping had a conflict of interest in inspecting these ships because their fee was in fact paid by the ship owners.
Because of Colicchio's determination, mandates were created to improve the shipping industry and prevent similar loss of life.
Well, the legacy of the Marine Electric is a very positive one. Its loss, arguably the worst loss in American commercial maritime history, produced a lot of very positive changes.
Number one, there were much tougher Coast Guard inspection standards placed so that these old ships were removed from the water. Secondly, ships that plied the North Atlantic during the winter had to carry survival suits. And the third major reform was the institution of the now famous U.S. Coast Guard Rescue Swimmer Team that helps people who are in very cold water who can't help themselves.
In 2001, a memorial was erected at the Massachusetts Maritime Academy to the 31 souls who succumbed to the sea that fateful night. By giving their lives to the ocean, the crew of the Marine Electric actually prevented countless others from suffering the same fate. They left behind a legacy of reform and justice. The Marine Electric was not the only T2 tanker to meet a disastrous fate in frigid waters. On February 18, 1952, two T2 tankers broke in half and sank off Cape Cod when their high-sulfur World War II-era steel became brittle and failed during a severe nor'easter. Engineering disasters will return on Modern Marvels. The aviation industry as we know it today has been shaped by ingenuity, daring, and disaster. One of the most influential disasters occurred the morning of March 31st, 1931. A Fokker F-10A, a tri-motor airplane, was on the field in Kansas City and ready to fly with 8 passengers and crew. It would be their final journey. In fog, ice, and very low cloud cover, Flight 599 suddenly took a nosedive and crashed near Bizarre, Kansas.
As we came over that hill right south of us here, we could see the tail section sticking up right out of the middle of a big pile of rubble.
All aboard the plane were killed, including one of America's most beloved heroes, University of Notre Dame football coach Knute Rockne.
To this day, he's regarded perhaps as the greatest college football coach that ever lived. But at his day, he certainly was the greatest of that breed.
Rockne led the Catholic University of Notre Dame to 3 national championships and 5 undefeated seasons during his coaching tenure.
They do not justify defeat. Those lads do not feel sorry for themselves, but they stick in there and give the best out of themselves until the last whistle blows.
Rockne boarded the TWA Fokker F-10A at the peak of his popularity. The United States plunged into mourning when it learned that the sports legend had died. It didn't take long for the aeronautics branch of the government to begin an investigation.
It wasn't investigated in the most rigorous manner because, let's face it, there wasn't a lot of experience investigating commercial aircrafts. So there's been a huge amount of speculation about what happened in that crash. When the Federal Civilian Aircraft Agency attempted to investigate this crash, they continually bungled it.
At that point, when commercial aviation was getting more prevalent and passengers were flying, and particularly because of the celebrity status of Knute Rockne, they started looking into why it crashed so that we can prevent this from happening again.
It had been only 28 years since the Wright brothers flew at Kitty Hawk. The predominant use of aircraft was for U.S. mail delivery, and these planes frequently crashed. By the late 1920s, new airplanes had been developed that had more powerful motors and could accommodate passengers.
The airlines were just beginning to coalesce in the late 1920s. It was very novel. Remember, it was only in 1927 that Lindbergh flew to Paris from New York. But the technology was improving literally every month.
The passenger airline industry had begun to emerge, and one of the most widely used planes was the Fokker F-10A trimotor. It was made with a steel body, but it had a wooden wing close to 80 feet long, and it was wrapped in a light-painted cotton material. With 3 Pratt & Whitney 420 horsepower engines, the F-10A flew at a top speed of 135 miles per hour.
Because it had these 3 engines and all this horsepower, and because it had this huge wooden wing, it had a lot of lift.
The wing was bolted to the fuselage, and the motors were bolted to maple blocks built into the wing. Anthony Fokker designed a wooden wing knowing it would be easier and faster to repair. A metal wing needed special parts and tools. Not so with wood.
This plane's going to be used all over the world. If it crashes, you got to be able to fix it. So you're going to have a lot more people that are used to dealing with wood.
Unfortunately, this practical decision would doom the most successful plane on the market. Sifting through the wreckage in the middle of the empty Kansas field, Experts in the investigation proposed a number of different theories for what happened.
The propeller was broken loose by ice. The pilot flew it into the ground in a spiral. They oversped. There were all sorts of excuses being offered, none of them the result of good investigatory work of the crash.
On May 4th, 1931, barely a month after the crash, the government banned passengers from flying in Fokker F-10s, all the while claiming there was nothing inherently wrong with the Fokker aircraft. Finally, the investigators identified the probable cause of the crash. Part of the wooden wing had broken off in mid-flight.
It came fluttering down much like a piece of paper 30 seconds to a minute after the plane had hit the ground over here.
The Fokker wing was comprised of wooden joints that were glued together.
If the wood gets wet with rain or there's moisture that accumulates inside the wing, it tends to separate and the glue joints start coming apart. And that is one of the things that they feel happened with this airplane.
So it doesn't have to rot to come apart. It just has to swell in a way that the glue cannot tolerate, and you break up the wing and you still lose the structural integrity.
The decision to make a wooden wing was a practical one for repairs. But in reality, such thorough maintenance for the growing fleet of planes and routes was impractical. The government and TWA, who owned the vast majority of the Fokker F-10A airplanes, weathered the disaster with little fallout. However, Anthony Fokker and his airplanes in the U.S. were virtually done in. Soon the entire fleet of F-10 planes was disassembled and burned. No one wanted to fly in them, and new regulations for inspections were too costly to consider. With the loss of Fokker and his fleet, however, the race was on to engineer a new plane.
Well, if Knut Rockne had never crashed, would we still be flying around in wood Fokker trimotors? I don't think so. But the market would have evolved very differently. Disaster tends to spur technological innovation.
In the aftermath of the Rockne crash, Jack Fry, the owner of TWA, contracted Donald Douglas to build a new, bigger, and better plane. This was the dawn of the DC-3, the plane that many believe was one of the best passenger planes ever made. The Walt Disney Concert Hall opened on October 23, 2003 in Los Angeles. It was lauded in the world's press as one of the most beautiful, dramatic, and innovative structures ever built.
The new Disney Concert Hall in LA is truly a modern architectural masterpiece in the sense it's a very free-form structure whose skin is stainless steel.
But there was a small, hard dose of reality in this fantasy land. Embedded in the graceful curves of shining metal was a tiny engineering disaster. Superstar architect Frank Gehry designed this new home for the Los Angeles Philharmonic Orchestra. The Disney Concert Hall is part of the Music Center complex, owned by Los Angeles County. Gehry fashioned the wavy stainless steel exterior to look like a ship with its sails at full mast, a symbolic ceremonial barge to music.
He wanted the structure to reflect light in different ways, so it would be a more interesting shape.
Although some criticized the ambitious design, everyone praised the acoustics. However, the sail-like designs that reflected sound so beautifully on the interior caused reflections of a different kind on the hall's steel-clad exterior.
Most of the Disney Concert Hall has a skin that is stainless steel. The brushed portions of the building tend to diffuse the beamed sunlight. The catch is that with the Disney there are some surfaces that are polished stainless steel, and they reflect very exactly the sunlight.
Two areas on the building featured polished stainless steel: the roof of the Founders Room and the marquee above the adjoining Red Cat Theater. Although these reflective areas only made up about 2% of the building's skin, they caused positively sizzling problems.
Sections of the wall are concave, so they focus the sun the same way a parabolic mirror would focus the sun. And so instead of having just the intensity of the sun reflecting back at you, You might have the intensity of 20 suns reflecting into your window all at once, and that's severe.
Nearby condominium residents got a blistering dose of this focused sunlight. Certain residents were unable to use their own living rooms because of the heat, and their air conditioning bills skyrocketed.
A flat panel like this, the light will come in, and just like a mirror, will go out parallel. You'll see the image. If you're standing over here, you'll see the image of the sun, for example. If we imagine that this were curved, then what would happen is all of that light gets focused into some point in front of this. If it's a very tight curve, the point is very close. If it's a very flat, open curve, the point is very far away.
Not only did adjacent structures get overheated, the physical space around the concert hall was heating up too.
You had measurements being made on the sidewalk of 140 degrees.
If the heat wasn't bad enough, certain traffic intersections were precariously close to receiving a blinding glare, which could have proven deadly for pedestrians crossing the street. The county responded immediately.
If you're going to cure the solar concentration problem, you have one or two choices. You can change geometry of the mirror or destroy the mirror.
A computer model simulated the shifting position of the sun at half-hour intervals over a 365-day period. This study determined which stainless steel panels were the worst offenders, based on time of day and season. LA-based Schiller & Associates conducted the study and assisted Gary in exploring different remedies to the problem.
Right, what we did was we tested different solutions. We just used one of the panels from the building and put different films on them, and we tested each of the surfaces to see what the different specularity would be. And some of the surfaces where a big aesthetic change may have solved the problem, but would have been a wildly different building. And I don't know whether you can see the difference in the way that the different surfaces reflect. You can see that there are certain moments when the focal point passes right through your eye.
In March 2005, the sails on the Disney Hall lost a little of their luster when work crews began sanding the problematic panels.
The best solution, the one that had the least aesthetic impact, but still was sufficient, was to sand the surface. We found that a combination of straight vibrational sanding followed by orbital sanding took care of the specularity.
It took 6 weeks and $60,000 to complete the process. Mission accomplished. Heat and glare dissipated.
Most people cannot tell that it's been treated. Those who do, I think, seem to find it interesting.
This engineering disaster may have been minor, but with modern building materials and a growing desire to push the architectural envelope, new dangers could be right around the next curving corner.
The heat island effect is something that goes on in cities now. In fact, cities now are so crowded full of inanimate surfaces that when the sun shines, they get hot. Now, this actually means that the air in the city starts to rise, and you actually get sort of air pulled in from around the city, which helps a tiny bit, but it's also an indicator that the city has overheated itself.
But for today, the Walt Disney Concert Hall stands gracefully in all of its dulled glory.